This is activity number 2 for lesson B-17. For this activity, you will need the assembled Raspberry Pi setup from previous activities, as well as the assembled circuit from the last activity. In this activity, you will build a program that will charge your capacitor circuit, and then measure the time it takes for the capacitor network to discharge from 3.3 volts to around 1.4 volts. The measured discharge time will be displayed in the console. Open Thonny and save a new program to the desktop called Discharge_time. This program will use the RPi GPIO and time modules as well as the BCM pin mode. You will also use a variable named pin to hold the GPIO pin number that will be used to measure your capacitors. Go ahead and set these up at the beginning of the program. Now, a quick note. By referring to the variable pin instead of pin 20 throughout the rest of the program, you can easily reconfigure this program to use a different pin later just by modifying this one value. If you use the number 20 throughout the program, you would have to modify every instance of this value if you wanted to reconfigure the program to use another GPIO pin. Next, use a try except loop that will catch keyboard exceptions and run a GPIO cleanup. The try loop should also contain a while true loop so your main block of code will continue looping. Add this code to the end of your program. Now that the main framework of the program is in place, add the program inside the while true loop. The first step in the main program loop will be to push GPIO 20 high for 3 seconds to charge the capacitors. The value of pin will be used to configure GPIO 20 as an output, push GPIO 20 high, and then wait for 3 seconds while the capacitors charge. The capacitors have been given time to charge from the 3.3 volts supplied by GPIO 20. It's now time to switch GPIO 20 to an input, store the current time as time start, and hold the program in a while loop as long as GPIO 20 is still high by using the pass command. This will cause the program to stay in the while loop until GPIO 20 transitions to a low state. The pass command is used as a placeholder and tells the program that you do not wish for anything to happen inside this while loop. You're only using it to delay the program right up until GPIO transitions low, and then the rest of the program will execute. The while loop has now held the program in place until the capacitors discharge enough for GPIO 20 to register as low. Once this occurs, you want to store the current time as time stop and create a variable named timer that's equal to time stop minus time start. This will find the difference between the start and stop times and store it in the variable named timer that will be printed later. Now that the discharge time has been calculated and stored as timer, print the first 3 decimal places of that value using the percentage notation formatting along with the word seconds. Add the print statement you see here to the end of your main loop. Run the program and watch the discharge times that are reported in the console. With both capacitors in parallel, their capacitance adds together, so you have 220 UF plus 2200 UF, or 2420 UF of total capacitance, resulting in a discharge time of around 0.840 seconds. You can drastically reduce the total capacitance by removing the 2200 UF capacitor from the circuit. With your program running and displaying discharge values, remove the 2200 UF capacitor and watch what happens to the discharge time. The times you see reported here will not match your figures exactly due to slight differences in AC power supply voltages and variations in capacitors. The average values went from around 0.840 seconds with 2420 UF of total capacitance to around 0.084 seconds with only 220 UF of total capacitance. This shows you how much energy storage capacity is added with the 2200 UF capacitor. With only 220 UF of energy storage, the circuit discharged from 3.3 volts down to around 1.4 volts in 0.084 seconds. By adding the 2200 UF capacitor and increasing the total capacitance to 2420 UF, it took 10 times as long to discharge the capacitors from 3.3 volts down to 1.4 volts. Save your program and keep the circuit assembled. Go ahead and move on to the next activity when you're ready.